And so I took some classes at ASU and started doing research in behavioral neuroscience with the intention of being like, I want to get into medical school. I know that I need to do research. But through this, I discovered a whole other side of science that I never really knew existed. So kind of having the bridge between like the science that I learned in the classroom, but also like direct application to, the brain, it was really neat for me to have.
From the cubicle to the lab, the studio to the war room, climbing the corporate ladder, or joining a scrappy startup, experience a day in the life of the jobs you want.
You're now listening to the Experience a Diddle podcast. You'll hear from professionals, entrepreneurs, and recent grads, all inspiring you to gain experience beyond the classroom and launch a career of your own.
We're your hosts, Christabel
and Matt Poe.
Welcome to part 1 of the 3-part Experience a Diddle series, Life in the Lab with neuroscientist Dr. Thu Huynh. In today's experience episode, we're going to walk you through Thu's career journey step by step to help you figure out if this field is right for you. The education you need for this line of work could cost too much money and tons of time for you to just wing it and hope for the best. Thu's story will clear up some things about navigating academia and skills that you'll definitely want to know about before you make this important investment in your career. Let's get right into it.
I am Thu Huynh. I am a postdoctoral fellow in neuroscience at Cornell Medicine. I have a PhD from NYU in neuroscience, and then now I'm doing an additional step of training.
Thu went to the University of Arizona and studied cellular and molecular biology with hopes of getting into medical school.
What made you choose this? Did you wake up one morning when you were a kid and say, I want to be a neuroscientist?
Definitely not. No, I spent the majority of my formative years thinking that I wanted to go into medicine.
Okay.
I always wanted to be a doctor, and that was my plan even upon graduating college. But I didn't get in after. I don't even know if I applied my senior year of college. But getting into medical school these days is very competitive. Mm-hmm. It requires like stellar undergraduate grades, a great MCAT score, tons of research, volunteer work, and things like that. And, a lot of things have to align. And so when I graduated college, I knew that I had to, expand my portfolio, get some more coursework under my belt, and start doing research, which I didn't really do in college.
She might not have gotten the research experience needed for med school during undergrad, but did partake in her passion for teaching as a math and science tutor for high school students.
I have always loved teaching for a very long time, and especially the subjects that I loved the most. I really loved to, if someone was struggling with it, I wanted to help them through it, just because I loved chemistry so much that if I saw you struggling with chemistry, I'd really want to see if I could be the one to
crack the code.
Exactly.
Yeah.
Exactly.
That's so cool. Was that volunteer or was
paid?
Paid. Cool.
Yeah. Yep.
Nice.
Yeah, you learn through teaching, right?
Definitely.
How much did you learn, just by teaching people?
Well, I learned that I didn't know some things that I thought I knew. I tutored this student in AP chemistry, and even after taking a couple of semesters in chemistry in college, I was like, whoa, this is still a little bit above my head.
Right?
Yeah. Yeah.
And that's okay, because you're still in college,
Exactly.
right, at that point?
Exactly. Yeah.
You don't have to be a genius right off the bat.
After earning her bachelor's degree, Thu lived at home for a few years, and she took classes to gear up for medical school. And it was during that time period where she had her light bulb moment and pivoted her career path.
And so I took some classes at ASU and started doing research in behavioral neuroscience with the intention of being like, I want to get into medical school. I know that I need to do research. But through this, I discovered a whole other side of science that I never really knew existed. And I think part of that was because it was an area of research that really piqued my interest, I guess, because in retrospect, I did spend a summer in a biochemistry lab, which was great, but, it was studying photosynthesis, which I wasn't really that interested in. So kind of having the bridge between the science that I learned in the classroom, but also direct application to, the brain, it was really neat for me to have.
That's proof that it's never too late to pinpoint your passion and run with it. But getting experience early on can help you get to that point so much quicker. One of Thu's many pieces of advice to pre-med students is to take your research requirements seriously.
I totally support pre-med students that are going to do research, but I always say that that if you really love science, that you should really love research too. And you don't have to spend your life doing it. I totally get people that do it, but you should take it seriously and see this side that is really enriching and can enrich what you learn in the classroom. That's different than what you learn in medical school,
Did you know you didn't need your master's to get your PhD? I didn't know that, actually. Tuz says if you want to get into a PhD program for neuroscience, there's a job that could get you experience you need, and you won't have to shell out hundreds of thousands of dollars for your master's.
So typically, like what I understood the academic path was, is that you get your bachelor's, you get your master's, and then you move on to your doctorate.
So this is a very interesting point that you bring up, is that a lot of people who plan to get their PhD want to take that master's stepping stone. But honestly, there is some merit to the master's, right? There is additional coursework and there is a research experience. But the major downfall about it is that it's paid out of pocket, unless you're lucky and you can get some kind of scholarship, which does exist, but not, they're not like very ubiquitous.
Very frugal.
So for the person who is planning to get a PhD, my major recommendation always is to get a technician job. The technician job will get you the research experience that you need. It's paid. And if you're at a university, oftentimes they'll give you like 12 credits that you can take as being a university employee.
Nice.
So what kind of what do you mean by that?
So in the lab, there are a couple of different kinds of people. There is, all the makeups are very different, but in general, you can have a technician, a lab manager, a graduate student, a postdoc, and then sometimes visiting rotation students.
Okay.
So the technician is someone that is going to do like some of the ancillary lab work. It will start with the like lower responsibility things like doing the dishes for the lab, which, like a lot of tedious things that need to be done. You can do ordering, which also the lab manager does. But slowly, if you show your worth, then they'll give you maybe a little side project that the lab has been meaning to do, to give you kind of your own experience and own project, which is really important to have when you're trying to enter like the land of research.
Get your foot in the door.
Exactly.
Okay. How do students go about getting those jobs? Is it just, are they on job boards, or do you have to network your way through it?
Sometimes you just have to cold email tons of labs, and just very short. So the kind of PIs or professors are notorious for not fully reading emails. I think as many of us are. But kind of the key is to write 1 or 2 sentences. I'm so-and-so. This is my experience. Are you looking for this? And in fact, that was like similar to the email that I sent when I was trying to find a postdoc. The short and sweet are really good. Typically, if someone's looking for a technician or a lab manager, they'll see that and want to email immediately. So, yeah.
Nice.
Gotcha.
Cool.
I think that's very important. I don't think a lot of people know that right going off.
Definitely.
Going into it. So.
Definitely. And then I guess the point is that once you have the technician job, you get the research experience. That's what you really need to get into a PhD program, and PhD programs are fully paid most of the time in STEM.
Awesome.
Yeah.
I did not know that.
Yeah.
Either.
Wow. That's awesome. I picked the wrong profession.
Yeah, did I go the wrong way?
Not fully paid a lot, but
Right,
they
a
are
lot
fully
paid.
paid. Yeah.
And that's paid by the university, just grants?
Everything.
Everything.
Sometimes
Okay.
universities, sometimes like training grants that are funded to the university, sometimes through private grants, or a lot of times the NIH. When you're first or second year grad student, then you can apply for your own fellowship. And that's also good to show on your CV for the next steps.
Sweet.
Gotcha. Cool.
Okay, so we now know that the master's programs make you pay out of pocket and PhD programs are mostly funded, but there's so much work that goes into getting your PhD that I bet you're wondering how she can afford to, live.
Different universities around the country, they have different stipends for graduate students based on the cost of living. So I think right now the stipend for an NYC graduate student is somewhere around $32,000.
Okay.
Which is, it's
Gets you by.
yeah, like people will
Feeds you.
say, depending on the number of hours that you work, like the hourly rate is not great.
But you're like building equity in your knowledge.
Exactly. And then if you go to some place like Columbia or Cornell, you have graduate student housing. So you have subsidized housing, which is super helpful, as we know, in New York.
That's nice.
Yeah.
So I want to ask about like just the culture of getting your PhD, like in the school. Do you have a community that you fall back on? Is it like, are you friends with the kid sitting next to you, or the man, guy, girl sitting next to you, woman?
So, you know, people talk a lot about the mental health of graduate students these days because, you know, it is important to have a big community and someone to fall back on. And sometimes you don't, and sometimes you do. And I would say that, you know, it's super important to find that community anywhere that you can. And so for me, when I had just started my PhD, I started with, I think it was 12 other students. I was in a cohort of 12. So these PhD cohorts are typically very small unless they're part of an umbrella program, which is like a lot of different, not majors, disciplines. If there are a lot of disciplines in one. But for neuroscience, it was just 12 of us. So we were very tight-knit my first year. And then following my first year, at least in my curriculum, you find a lab your second year, and then that kind of became my family. And at least in my PhD lab, we got paired with a postdoc who kind of was the one to take you under their wing and teach you everything that you know. So if you get really lucky, as I did, and get paired with a great mentor, then that's kind of the person that you learn everything from, but also really rely on for like emotional support during like the difficult times of the PhD.
Definitely.
Yeah.
Okay, cool.
That's awesome. And then I did some research on like the course structure of the program.
Okay.
And at first, the first year is just like core classes, kind of like undergrad as well. And then the second 2 to 3 years, you're, you know, focusing on your area of study. And then you have the option to become a TA. Were you a TA?
Yes, definitely.
I figured you were.
And that was just... I think what you had mentioned, Matt, before about learning as you teach was really important for me also as a TA because I took coursework my first year of my PhD, and then I started TAing, I think, my third, fourth, and fifth year of my PhD. I did an extra semester of teaching because I loved it so much. But, you know, like when I was TAing for an intro to neuroscience class, it is introductory, but at NYU, you know, the neuroscience major is actually quite tough. You get re-exposure to all of these things that maybe you hadn't touched in a while. And so then it kind of, if you're doing research at the time, it's like, oh, that's something that I didn't think might apply. And so then you can kind of go back to your own work and...
Nice refresher.
Definitely.
Yeah,
it was,
awesome.
and it was just, it was really nice because, you know, as I mentioned, if the students, they get the single exposure to the professor a couple times a week, you know, but, you know, if you're too shy to go to office hours, the TA is really important for undergrads. They feel a little bit more comfortable asking questions that they wouldn't otherwise to the professor. And it was really nice for me to have that experience.
Cool. And then just like a brief pre-diddle, I guess, of a PhD student. With you doing a TA program and things like that, how did you balance your work, which is super intensive, with work?
So
TA?
It's tough. And I mean, you have to ask for help.
Definitely.
You know what I mean? And I think that was something that I didn't know how to do so well at the beginning of my PhD, was how to balance and also know what my own limitations were. And so, yeah, when I train undergrads or graduate students now, I am always very firm about, you know, like set realistic expectations for yourself, because I was very bad at that. So I think that's something that I try to pass along.
What was graduation like?
Graduation was super anticlimactic.
Really?
Yeah.
Okay.
Was it?
Yeah. Well, it depends. So, what happens in the PhD is that you have to schedule your PhD defense. So you're defending your research that you've done through your whole PhD. You have to schedule it in line with one of the school's graduations in the calendar year. So that's 3 of them, right? You have the spring and the summer and winter graduation. So typically all of the defenses happen in May, August, or December. And that's kind of that's the graduation. So that is really celebratory. It's your defense. You're defending the research that you've done for the past 4 or 5 years in front of the whole department. And then after your public talk, your committee, which you form during your PhD, consists of, depending on the school, 4 principal investigators or professors that are in the department that know kind of your field of research. They guide your research throughout your PhD, but they're also the ones to eventually give you your PhD.
Okay.
So you give your public talk, and then they take you into a room and they kind of grill you about big picture questions. Sometimes they'll read your 100+ page dissertation and go through things that they saw. Sometimes they don't read them. That wasn't my experience. I got copies of my dissertation back that had notes scribbled in them.
Wow.
Yeah.
Okay. So what do you mean? Like they don't read them?
Sometimes they don't read. They're very long. Wow. They're really long, and
just like the talk like kind of sums everything up for them. Okay,
yeah,
I always thought that the dissertation is like that. You know, that's the whole research, and then without that, you wouldn't.
Right.
Pass,
you definitely need it, but then there's sort of the argument that maybe it's a little bit of a formality.
Interesting.
That's not to say you shouldn't take it seriously. I think it's a personal feat type thing, right?
You know, like have everything all laid out
exactly
to the fullest extent.
Yep.
I'm into it.
I always thought once graduation day hits, you're done and you move on to the next task at hand. In Tu's case, more research, but sometimes there's way more work to be done.
So the thing about research is your success is judged by the number of publications that you have. You know, you can get straight A's in your PhD, but if you, even after graduating, have 0 papers with your name on it, that's, you know, not the most successful PhD experience. And so people, again, judge you by the number of papers that you have. And this is a research that you do during your PhD. This is what the goal eventually is to submit your work to a peer-reviewed journal and then to get it published so you can list it on your CV. So if you look at a science CV, you'll see at the very top, one of the first things is peer-reviewed publications. And that's where people look to see your productivity. And if you're in research, that's what people really care about.
Interesting.
And so I had a couple of papers in my PhD, but I was wrapping one of my projects up, and so I needed a couple of months. So sometimes the PhD defense is not commensurate with like finishing your time in the lab. Oftentimes people will stick around for a little bit longer to wrap up their research because like if you don't have that published, then it's almost meaningless. So from my PhD, I had 3 first author papers. So you know,
first author means you're the first name.
Exactly.
Okay,
so,
cool.
So lab work is super collaborative. There's always people that have their hands in the project, and it's important that you give them credit to that. So that's to put their name on the paper. And so when I had mentioned the technician job being a really good stepping stone is if you play your cards right, then you'll get onto a paper that's going to be published. And that really matters for getting into a PhD program.
Oh, nice. So then what are the actions needed to be like a second name or a third name?
Second name often is significant work also put in with the first author. Oftentimes these days we're seeing co-first author papers. So these are people that contributed equally and as importantly to the paper. And then anybody basically, I mean, it's a matter of ethics too, right? If someone helps you with their project, then they should be given credit for it. And so this is also something that has to be discussed before you start working on a project, is to ensure that you will get the credit that you deserve.
Awesome.
Yeah.
Cool.
There's a lot of little details that I didn't think mattered.
Yeah.
That I guess do
totally
matter a lot.
Yeah. Yeah.
It's very enlightening. So after graduation, what was going through your head? What, where did you see yourself to just kind of fall into place?
So I defended my PhD in September of 2015. I got married November of 2015. And then we went to Italy in December of 2015, and I started my postdoc January of 2016. Okay. And
kind of nice little break there. Right?
Yeah, but it was, for me, it was this very weird moment because, I'd been working so hard to get my PhD, and then I got married, and there were all these really big life events, right? And some, like a lot of these things are like check boxes, as you're growing up, it's like, well, I need to do this, and then for me, before starting my postdoc, I was like, man, all of these things are done. Where's my life going now? And I remember being in Italy and thinking, oh man, I only have 5 more days left of vacation, 4 days left, 3 days left. And then I realized that, at this point in my life, just being present and in the moment and not looking too far back and not looking too far forward was really important for me, and just to kind of live and enjoy every moment and just to be present. So So I think that mentality in starting my postdoc was really important for me. And what I also didn't realize was that I was starting completely new work. And I forgot how exciting that was, right? You know, near the end of your PhD, you're starting to do experiments that you kind of put off for a while, or you are doing them to have appropriate controls for the papers that I talked about. And it gets kind of tedious and boring at the end. And so I think that that was kind of mixed into my feelings, and I forgot how fun science was. And so January, starting my postdoc, was a really fun time for me, actually.
That's awesome.
Can we get into the specifics of what research you were doing?
Yes.
As much specifics as you can get into?
Sure. Okay. So when I was in my PhD, my initial question was how memory consolidation occurs. And so memory consolidation is the process of how a memory becomes long-lasting.
Okay.
And I studied the molecular mechanisms of how this occurs. Mm-hmm. So I studied the role of new protein synthesis in this using a mouse model. And so in this mouse model, we used a modified form of like Pavlovian associative conditioning. So we all know the study of Pavlov and his dogs, where a bell would ring and a dog would get food, right? And so when the food is presented, the dog salivates because he's hungry. And then the dog learns to associate the sound of the bell with the food. And so as soon as he hears the bell, then the dog starts to salivate. And this is what we call a conditioned response. And this conditioned response is a memory. Mm-hmm. A memory of the bell being a predictor of food. Okay. Right? And so I study kind of this process in a mouse model using aversive conditioning. So here, instead of food, the mice receive a little bit of a shock after a tone is being played. And so what the mouse learns then is that the tone predicts this mild foot shock. And then in subsequent presentations of the tone, they'll freeze a little bit because they anticipate being shocked. Okay. And so this is a really robust kind of memory that you can study. And we know the brain regions that are involved with this memory process. And so I studied that in my PhD, and I transitioned now into my postdoc by studying kind of the neural circuits that are involved with this process by using some of the imaging techniques that I had mentioned when I was searching for a postdoc.
Nice.
Okay, cool.
So yeah, the imaging techniques these days are, the neuroscience is advancing like at a very, very fast rate, and it's very cool. It's a very cool time to be in neuroscience, but we have these viruses that are non-toxic, and when you put them in the brain, they will allow the neurons to flash on and off when they're active, and you can capture this activity with a fiber optic and kind of say something about how the neural dynamics associate with behavior, in this case, the conditioning that I was talking about.
Nice. So with your bachelor's degree and your PhD, of all your experience in between, you chose the route of research and education sort of fields. What are other fields that neuroscientists could get into if they didn't want to go down those routes?
So one part of neuroscience that is really important right now, or something that really applies to neuroscience, is like big data and the ability to program, right? So you can imagine that all of these neurons, there's like, I think trillions of neurons. I think trillions of neurons in the brain, and in a single brain region, you can capture hundreds up to thousands of neurons being active at a single moment. So how do you unpack all of this information? It's through programming. So a lot of people have different programming languages. And so going from neuroscience, you can go into programming, yes, but also I would say the opposite, that if you're into programming and engineering, then you can also go into neuroscience. So it's kind of like a nice symbiotic relationship.
And then you're also an associate professor, correct?
Yes.
At Hunter's College?
At Hunter College, yeah. So actually, this kind of brings me back to the whole process of finding the postdoc, which was that it was really important for me to find some place that I could also teach. And this is, I was kind of weird in this way because a lot of people that have their PhD, they don't like teaching. And so when I told a few people, I really want to teach during my postdoc. People would say, why? Why do you want to do that? I love teaching, and so it was important to me to get that experience. And there are a couple of NIH sponsored fellowships for postdocs that allow you to teach and do research at the same time. So I was really gunning for one of those positions. But unfortunately, none of the research labs kind of aligned with the locations for where my husband was going to eventually be. And so this is kind of an internal struggle for me, because that fellowship I was like, it's perfect for me. It has everything that I want, and it gives dedicated teaching time, right? Mm-hmm. And so when I found the lab that I am now in, it was also very important for me to find a lab that I was very interested in. And that was my number one. Close number two was teaching. But when I started my postdoc, in my head, I was like, I have to find a way to get the teaching experience that I want. And so I would go online and I would look up all of the colleges around NYC. I tried to contact my NYU professors to see if anybody would have me, but being a postdoc and teaching at a place like NYU is, usually those jobs are reserved for full professors or assistant professors. So there was no space for me there. And so then I started emailing some of the city universities and got in touch with Hunter College, that adjunct administrator. And I actually was emailing several months in advance. I emailed the August when I finished my PhD, and nobody responded to me. And then I emailed again, I think in December. It was like, just reaching back out. This is my expertise. This is, I would really love a teaching position. And it just happened that the person was scheduling for the spring semester at the time, and was able to fit me in this behavioral pharmacology class.
Sweet.
So what's next for you?
So because I have the two-body problem, my husband just finished his fellowship, and we're moving to Arizona at the end of the summer.
Wow. Congrats.
Yeah,
That's
awesome. It's great. But I'm not done with my postdoc yet.
I was going to ask, how long are you doing your postdoc for?
So it depends. It depends on the research, right? Mm-hmm. So as soon as the papers are published, and it depends on where they're published, that sort of dictates the terms of your postdoc.
Gotcha.
So the standard postdoc, I would say, is somewhere between 4 to 6 years. And I am...
oh, wow. Okay.
Exactly. Yeah.
I'm thinking under a year here.
No,
wow.
yeah.
Holy crap.
They're long, and I'm only 2.5 years in.
All right.
So this is a little bit of a problem, but, separating the family wasn't something that we were willing to do. And again, my boss has been amazingly supportive, and I'm working remotely to finish my papers.
Wow. Nice.
Yeah.
In Arizona.
Yeah.
Wow.
Yep.
That's awesome. And you can work in a lab, find a lab there?
So not necessarily, but what I've been doing this whole summer is acquiring all of the data such that I can analyze it on a computer offline and then write up the manuscripts.
Sweet.
Yeah.
All right. Good for you.
I love it. We love Tu's story and thought it was so necessary to share it with you guys, because she went into college thinking she wanted to do one thing, and then came out a couple years later switching gears and is seeing great success and happiness from it. So I hope that gives you guys some perspective about your own careers, in that, genuine interest, love, and passion in the subject at hand is a huge aspect to consider when making those tough career decisions, especially you pre-med and STEM majors. So next up, part 2 of the Experience a Diddle's Life in the Lab series, which is the Diddle episode, where we'll experience a specific day, hour by hour, of a neuroscientist. Stay tuned.
Thanks for listening. Each week, we bring you interviews from professionals in the jobs that you want, highlighting each guest's career experience on Mondays, a day in the life on Wednesdays, and their advice to you on Fridays.
Visit our website, experienceadiddle.com, to find the show notes for this episode with all relevant links and photos. Also, don't forget to follow us on Instagram, LinkedIn, and Facebook at Experience a Diddle. That's Experience ADITL. And of course, we're here to help all students make more informed career decisions. Visit our website to read all Diddle articles from all different jobs and careers interviewed, written, and published for students by students. You can sign up to join the Diddle Army at experienceadiddle.com/students, and let's grow together.
We want to pay for your textbooks. As an ongoing contest, at the end of each semester, we'll randomly pick a winner from our subscribers who wrote us a review and buy all of their textbooks. So hit subscribe and tell us what you think about the show, and remember, you will be great.